Law of conservation of mass, calculations. I can make calculations relating to the law of conservation. Starter. The student inferred that a chemical reaction occurred. What evidence supports this inference? So observations of an investigation. So here you have zinc metal and your substance here. Then in this beaker, the metal is added to the beaker. And then your result is this. So here you see a new substance forming and a dark solid formed on the zinc metal. This would be your evidence that a chemical reaction occurred. Chemical reaction occurred because a new substance formed, a dark solid formed on the metal. Law of conservation of mass, video review.
In this video, we're going to talk about the law of conservation of mass. So what is the main idea behind this law? The main idea is that matter cannot be created or destroyed in a chemical reaction. So let me give you an example. Let's say if we react methane gas with oxygen. So let's say if we have a closed container and we're going to mix 16 grams of methane in this container. We're also going to place 64 grams of oxygen gas. So the methane and the oxygen gas, they cannot leave the container, they're stuck there. Now, as the reaction proceeds, it's a combustion reaction. It's going to produce carbon dioxide and water vapor, depending on the temperature. Now, let's say if you collect 44 grams of carbon dioxide. According to the law of conservation of mass, how many grams of water should you expect to be present at the end of this reaction? Now think of the total mass of the reactants. The reactants are the stuff on the left side. We have 16 grams of methane and 64 grams of oxygen. So therefore, we're starting with 80 grams of reactants. So before the reaction, we had 80 grams of matter. At the end of the reaction, according to the law of conservation of mass, in a closed system, you should still have 80 grams of mass. So if we have 44 grams of carbon dioxide, the remaining amount of mass should be water. 80 minus 44 is 36. So therefore, we should expect to collect 36 grams of water. And that's the main idea behind the law of conservation of mass. If you have 80 grams of material inside the closed container before the reaction, then when the reaction is complete, you should still have 80 grams of matter inside that container. In a chemical reaction, the only thing that's happening is that the atoms are rearranging themselves. Here, carbon is bonded to hydrogen, but now it's bonded to oxygen. So therefore, the total mass should remain the same. The atoms are simply switching partners. They're just rearranging themselves in this chemical reaction. But the amount of mass, the quantity of matter, should still remain the same. The only way you can change it is if you add more mass into the chamber or the reaction container.
So let's take notes for our practice. The law of conservation of mass. Matter cannot be created or destroyed. The mass of the reactant side must equal the mass of the product side. So this is the mass of your reactant side. It must equal the mass of your product side because matter can't be created or destroyed. If you begin with 100 grams of a substance in your reactants, you must end with the same amount, 100 grams. They have to be equal. For our activity, we're going to calculate the missing mass in grams for each of the equations. We'll click on the griddable to record our answer and then highlight the corresponding numbers underneath. So here we have 7 grams of a substance plus how many grams of a substance are going to equal 24 grams in our products. So what's the missing amount in our reactant that we need in order to have 24 grams? So over here you want to just do 24 and subtract it from 7, which is 14. So we can go over here and use our griddable. We can put 14 in like this, fill in our zeros. So in our ones place, you're going to highlight these corresponding numbers in your griddable. Make sure that your circles are fully covered. Okay, that's calculating the missing mass in grams for this equation. So here in your reactants, you have 20 grams of this substance plus 5 grams of this substance, which is going to produce 15 grams of this substance plus how much of this substance. According to the law of conservation of mass, your products must equal your reactants. So if you're starting with 25 grams here in your reactants, you must have 25 grams in your products. So what's the missing amount? 10. 15 plus 10 will give us 25, so the mass in grams of our product will equal the mass in grams in our reactants. How will we grid the whole number 10? Here's your decimal, and it's not necessary that you put the zeros, but we will. And you want to make sure that you fully highlight those. Oops, I'm sorry. Let's fix that. So 10 would be gridded here and here. Our next chemical equation, we're finding the missing mass. So here in our product side now, we can see that the mass of this substance is 31 grams plus the mass of this substance is 3.7. So first we want to know, well, how much is, or how much are our products in grams? So let me get our web paint. And so I'm going to come down here and I'm going to add 36.1 plus 3.7 to get the total mass of my products. So 1 plus 7 is 8. 6 plus 3 is 9. So the total mass of my products are 39.8. So my reactant mass must be 39.8 according to the law of conservation of mass that says matter can't be created or destroyed. The mass and the number of atoms in your reactants must equal the mass and atoms of your products. Matter can't be gained or lost. So let's go over here and grid 39.8. And then you'd come down and fill in those bubbles. And on to our next problem. So here in our reactant side, we're missing this part of the reactant. We need to understand what the mass is. Here in this part of the reactant, we have 7.1 grams. Okay, these two substances react and they're going to produce this product. And here you see the mass of this product is 38.1. The mass of this product is 5.6 grams. So we want to know what is the total of the mass of our products. So again, let's get our web page. And we're going to add, this time, 38.1 plus 5.6. So we have 7, and then 8 plus 5, that would be 9, 10, 11, 12, 13. So the mass of our products is 43.7 grams. So what we need to do, if this reactant is 7.1, we're going to have to take 43.7 and subtract 7.1. And subtract 7.1. And we have 6.6. And let's go over here and bubble that in. And we can go to our next problem. And here what we have is the mass of our reactants and then our products. So part of our product mass is 28 grams, so we need to find the missing amount in our product. So according to the law of conservation of mass, my total of my product should equal 49.97. So what I need to do is take 49.97 and subtract 28 to get that missing amount. So let's do that. 49.97 subtract 28. So I can just bring down that 97. And 9 subtract 8 is 1, and 4 subtract 2 is 2. So the mass of my missing product is 21.97 grams. I would come over to my griddable and mark 21.97 and make sure that you bubble those in. That's what the computer reads. You want to really make sure you bubble in correctly. Okay. And then lastly, we're going to finish with a STAR test question on the law of conservation of mass doing calculations. It says a chemical reaction in which calcium carbonate is decomposed results in the production of 2 simpler compounds. What is the mass of calcium carbonate to the nearest hundredth of a gram? So here in your products, you have this product's mass at 28 grams and the other product's mass at 21.97. So to find the mass of your reactants, you just simply add these two numbers. According to the law of conservation of mass, your product's mass should always equal your reactant's mass. So 49.97, we'd come over here to the griddable and grid 49.97. For your exit, as part of an investigation, students combined substances in a beaker to observe chemical reactions. They performed 2 procedures. They measured the mass of each substance before and after the reaction. The table shows their observations. Assuming the students did not make any careless errors, what likely explains these changes in mass? So in procedure number 1, the mass of the reactants is 100 grams and the mass of your products is 97.5 grams. So it looks like we lost mass in the product. Okay, so what could have happened? Okay, so maybe gas escaped out of the container and into the air to give you a less amount in your grams. In procedure 2, your reactant's mass is 100 grams and then the mass of your product is 102.5. What could give you more mass in your products? How could we get added mass? Well, through error or so forth, we can always gain or lose matter. Here, a gas from the air reacted with another gas in the air, perhaps. Okay, so there are different causes of error that might lead to something like this. It's just a former STAR test question. These were the answer choices on the multiple choice questions. Okay.